Here's a quick video from YouTube explaining, the formula for the surface area of a sphere. So why is it 4 pi r squared? Let's watch it. It's pretty interesting.
Some of you may have seen in school that the surface area of a sphere is 4 pi r squared, a suspiciously suggestive formula given that it's a clean multiple of the more popular pi r squared, the area of a circle with the same radius. But have you ever wondered why this is true? And I don't just mean proving the 4 pi r squared formula. I mean viscerally, feeling to your bones a connection between this surface area and these four circles. How lovely would it be if there were some subtle shift in perspective that shows how you could nicely and perfectly fit these four circles onto the sphere's surface? Nothing can be quite that simple, since the curvature of a sphere's surface is different from the curvature of a flat plane, which is why trying to fit, say, a piece of paper around the sphere, it just doesn't work. Nevertheless, I would like to show you two separate ways of thinking about the surface area that connect it in a satisfying way to these circles. The first comes from a classic, one of the true gems of geometry that I think all math students should experience, the same way all English students should read at least some Shakespeare. The second line of reasoning is something of my own, which draws a more direct line between the sphere and its shadow. And lastly, I'll share why this fourfold relation is not unique to spheres, but is instead one specific instance of a much more general fact for all convex shapes in 3 dimensions. Starting with the bird's eye view here, the idea for the first approach is to show that the surface area of the sphere is the same as the area of a cylinder with the same radius and the same height as that sphere. Or rather, a cylinder without the top and the bottom, what you might call the label of that cylinder. And once you have that, you can unwrap that label to understand it simply as a rectangle. The width of this rectangle comes from the cylinder's circumference, so it's 2 pi times r. And the height comes from the height of the sphere, which is 2 times the radius. And this already gives us the formula, 4 pi r squared, when we multiply the two. But, in the spirit of mathematical playfulness, it's nice to see how 4 circles with radius r can actually fit into this picture. The idea will be to unwrap each circle into a triangle without changing its area, and then to fit those nicely into the unfolded cylinder label. More on that in a couple minutes.